Hello, good morning, good afternoon, good evening. We are simplifying in group language today. So what you're going to see is a lot of symbols and a lot of simplifying these symbols by using properties that we know. So first of all, remember that we're in group language, which means we are allowed to use closure, identity, inverse, associative. And we're going to be using abelian group language, so we will also be using commutative property. Okay, so by group language I mean that you're going to see expressions of elements that are in a group, an abelian group. You're going to see an operation, you're going to see identity elements and inverses of elements all together in expressions woven together with the operation in the group. And these expressions will be a little kind of long, not super long, and then we're going to shrink the expression down to as short as we can by using these properties. So these are the elements you're going to see. You're going to see A, B, C, D, etc. Those are the elements I'm going to use in my group language system. And the inverses of these elements will look like this. Inverse of A, inverse of B, inverse of C, inverse of D, and so on. That's how I'm going to write the inverse of an element. That doesn't mean an exponent, it's just an abbreviation of inverse of A. The identity element, I'm going to call it lowercase e. Okay, so that's the identity. And the operation you're going to see is star, or asterisk, whatever you want to call it. I call it star. So how do you simplify expressions that are in group language? Well, I'll start with one of the easier simplification maneuvers, which is using identity. So if I ever see anywhere any element starred with the identity element, I know that that automatically becomes A, because inverse identity properties tells me that anything starred with the identity results in itself. So if I see A star E, or if I see E star A, they will both become A because identity element works commutatively. And that goes for any element I see. B star E is B, C star E is C, and so on. I also know from inverse property that A star A inverse, or A inverse star A, equal the identity element. How do I know that? Because we are in group language, so my group has inverse property. That means any element has an inverse. So B has an inverse, it's B inverse. C has an inverse, it's C inverse. So if you see an inverse pair, they can create an identity element. I'll move on to a commutative. So anytime you see A star B, any two elements interacting together, you may change the order without changing the value of the expression. So it's legal to change this into B star A if you want. If you see this, any two elements starred together in parentheses, and then that starred with something else, you may change that into this if it helps you. You can do this because of commutative property. You can do this because of associative property. Okay? And then closure doesn't really come into play when we're simplifying things, but just know that we are working in a group and therefore the group is closed. Okay, so here's an example of an expression that we can simplify. Okay, so our job is to simplify this medium length expression. So just looking at the big picture, I see a pair of inverses here, B and B inverse. And I see a pair of inverses here, C and C inverse. And I know that if B interacts with its inverse, that it will create the identity element. So I would like to do that because that will shorten the expression. And I also know that C starred with its inverse will also create the identity element. So I want those two to interact with each other as well. But this B and B inverse are not next to each other, so they cannot interact at the moment. And the same with the C and the C inverse. They cannot interact at this moment. They must be next to each other. So I can accomplish that by using commutative property. I can change the order, right? Because this is group language. I'm in a group, so I can use any of these 5 properties. So I'm going to use in my first step commutative property. So I change the order. Like so. And when I'm simplifying expressions, I always have reasons for every step. And my reason must be one of these properties. So for this step, I already said it, I'm using commutative property. So my reason is commutative. I can only use one property at a time. So my next step is to group my inverse pairs, this pair and this pair. So I put parentheses around B and B inverse, as well as C and C inverse. And that is associative property. Anytime you put grouping symbols around elements that are being operated with each other, that's associative property. Okay, next I'm going to take each of these pairs and create the identity element, because these are inverse pairs. So there's one, there's another one. And the property I used to make an E out of an inverse pair is inverse property. Okay, now I want those E's to disappear. I know that anything starred with E is itself, so these E's are eventually going to disappear. So I'm giving you a little leeway here. Technically, the E's should disappear one at a time, one E per step, but I'm going to allow you to get rid of all the E's at once, leaving capital D. So the reason for going from here to here is identity property. Anything starred with the identity element is itself. Okay, so now you see that we have simplified this long expression all the way down to D in 4 short steps, 1, 2, 3, 4, by using one property each step, because I'm requiring you to use only one property each step. So no skipping steps, no using 2 properties per step, for now. Later on I'll be a little more lenient, but for now, 1 property per step. Okay, I'm going to do one more, and then we'll be done. Sorry, I'm going to change this to that, and I'm going to change that to that. And I'm going to put star C at the end there. Okay, so in this parentheses we have C star A, in this parentheses we have inverse of A star inverse of B, and here we have B star inverse of C, and then star C. Okay, so right off the bat I see some inverse pairs scattered. There's an inverse pair here, there's an inverse pair here, and there's an inverse pair here. This one is an inverse of B. Okay, the problem is I want to put these pairs together so I can make some E's, but I have these parentheses in the way. They're barriers, walls, and I can't move things out of the parentheses and move things in. So I just need to get rid of the parentheses, which I can easily do using associative property. So associative property can be used to add parentheses in, they can be used to move parentheses, or they can be used to remove parentheses. So I'm going to remove all 3 sets of parentheses at once. Okay, so this is nice because all the parentheses are gone, and this allows me to use commutative property to move these elements anywhere I want. So I'm going to use commutative property next to put all my pairs of inverses together. So C's first, so I'll put my C and C inverse here, and then my A and A inverse right next to that, and then my B inverse and my B next to that, and then there's an extra C over here. Okay, so I got a pair, and a pair. And now I'm going to put parentheses around all my pairs. Using associative again. And then I get to make my E's, 3 of them. That's inverse property. And then I get to make the E's all disappear at once. That is identity property. And that's as far as I can go. There's nothing I can do with that C, it stays. Okay, so again, we have 1 property per step. You can use that property in multiple places. So associative, you can put parentheses in multiple places. It's still the same property. For inverse, you can make e's in multiple places. It's still one property. And for identity, you can make e's disappear in multiple places. It's still one property, so it's legal. Okay, have fun simplifying.